बिस्मिल्लाहिर्रहमानिर्रहीम। अस्सलाम वालेकुम। उम्मीद है आप सब लोग खैरियत से होंगे। हमारा लेक्चर 5 जो कि तसलसल है पिछले लेक्चर में जो मेथड्स हम इनिशियल वैल्यू प्रॉब्लम को सॉल्व करने के लिए पढ़ रहे थे उनसे। इसमें हम कंटेंट्स हैं रंगीकुटा मेथड्स पढ़ेंगे। Here we'll be discussing the first 4 orders of RK method. RK first order method, RK second order method, RK third order and RK fourth order method. And then we'll be solving one of the example using these methods. Rangikuta methods. There are two main reasons why this Euler method that we studied in the last lecture is not generally used in scientific computing. I told you this is a very slow one, you have to take h very small, so there are so many reasons. But the two main reasons are, first, the truncation error per step associated with this method is far larger than those associated with other methods. So this is the problem number one with the Euler method, specific problem for a given value of h. Secondly, the other method is too inclined to numerical instabilities. So this method is having so much inclination towards the instabilities. So to overcome that situation, the methods most commonly employed by scientists to integrate ODIs were first developed by two German mathematicians, C.D.T. Runge and M.W. Kutta, in the later half of the 19th century. The main reason that Euler's method has such a large truncation error per step is that in evolving the solution from xn to xn plus 1, the method only evaluates the derivative at the beginning point only of the interval. So it gets the derivative at the xn. To compute xn plus 1, it computes the derivative at xn. So the method is therefore very symmetric with respect to the beginning and the end of the interval. Now, the Runge-Kutta methods. We know that solving differential equation numerically using Taylor series method to determine the higher derivative is a very lengthy process because you have to compute all the higher order derivatives. So to overcome this, there is a class of method which is known as Runge-Kutta methods, which do not require the calculations of higher order derivatives and give greater accuracy. I would suggest you here, you must look for the Taylor series method. I'll be giving you an overview there, but you must have gone through this Taylor series method earlier, but you also should again review this Taylor series method. So these methods agree with Taylor series solution up to the term HR. So first match is with the h1, second with h square, third with h cube, so on, where r differs from method to method, and this r is known as the order of the method. So just to give you an overview of the Taylor series method, you know this is the Taylor series expansion. So to find out the value of yn, you need yn minus 1 and derivatives yn minus 1 dash, double dash, triple dash, means the first, second, third, so on derivatives. So you have this first derivative, you know, from the original differential equation given, so then you have to compute all these derivatives again and again. So that's why this is basically the lengthy process for the Taylor series method. So to overcome that situation, Runge and Kutta together develop the methods, and they are of different orders. So we start with the first method, that is first order RK method. We have seen earlier this is the equation of the Euler's method. So if you look at the equation, this is y1 is equal to, for the value of y at x1, which is y1 is equal to y naught plus hf of x naught y naught, which is equal to, this is y naught, and this h, same h, f x naught y naught was what? This was the derivative's value. So we can write this in form of y naught plus h y naught prime. Now y1 is the value at y is equal to x1, and x1 is x naught plus h. So y1 is y's value at x naught plus h. Now we expand this by the Taylor series. So by expanding this one with the help of Taylor series, so y naught, first point means y at x naught, which will be y naught, plus h y naught prime plus h square by 2 factorial y naught prime. So this is a simple Taylor series expansion. So this is a Taylor series expansion. Look at these two equations, compare these two equations. This implies that this Euler method agrees with the Taylor series solution up to h, term h, including h. So mean here r is 1, h power r. So here h is r is 1. So means RungeKutta, this is why, since this r is equal to 1, so this is why this is known as a RungeKutta method of first order. So RungeKutta first order method is the Euler method only. So the in algorithmic form we can write this RK first order method as, so if you look at this equation, so actually the algorithmic form is, we want to know what we increment will made in the yn to get yn plus 1. So we are interested to find out this k, this increment. So from this equation, if we substitute this one is equal to k, if we took this one is equal to k, this will become y1 is equal to y naught plus k. So this is algorithmic form. Why? Because you just have to compute all the time k using this technique in algorithmic form, and all ways to find out this next term, you just have to substitute k here. So this is why this is written in the form of algorithmic form. अभी आप अगले methods में देखेंगे तो you will be get more clear about the things कि किस तरह से ये algorithmic form में लिखने से फ़ायदा होता है, जिससे हम easily iterations computer की मदद से या फिर हम इनको by hand भी करना चाहते हैं तो easily we can do that. So this is actually the algorithmic form of the RK method of first order. So this k is called the increment. So first order RK method is what? This is only the Euler method. So Euler method से coincide कर जाता है ये, और first order क्यों है? क्योंकि ये मैच करता है Euler method इसके फर्स्ट टर्म तक, यानी h की पावर 1 तक coincide कर जाता है. So इसलिए इसको first order RK method बोलते हैं. So now second order RK method. We know the improved Euler method formula is y1 is equal to y naught plus h by 2 f of x naught plus y naught plus f of x naught plus h, and y naught plus h f of x naught y naught. You know this from the last lecture. I just recall that formula, remind you that this was actually the slope of the average of the slopes of line tangent at x naught y naught, and the line which is having slope f of x naught plus h and y11. So this is the value of y11, if you remember that from the last lecture. So actually this was the final formula we have for the improved Euler method. By Taylor series we know y1 is equal to, as we did in the RK first order method, this is the Taylor series expansion. This will be y naught plus h y naught dash plus h square by 2 factorial y naught double dash plus h cube by 3 factorial y naught triple dash, and so on. Now if you look at these two functions, this is f of x naught y naught. If you look here, so this is a function of two variables. So we want to make expansion to this function Taylor series expansion for the two variables. So we are making the expansion to this function. So now expanding this function by Taylor series expansion of two variables. So if you recall that this was y1 is equal to y naught, initial value for the y naught plus difference h by 2. So this is the value we have already. Y naught is the similar, this one, h by 2 is the similar, f of x naught y naught is similar. So now from here we are starting the expansion of this function. So this function expansion is starting from here. So what will be the expansion? Expansion to this function will be f of x naught y naught, this is here, plus change in x means h, partial f by partial x at x naught y naught, plus h, here it should be partial f by partial y at x naught y naught. Here since it was x, so here we have partial x by dx, so which is 1. So in this case here it will be partial y by partial x. So in other words, since it's a one dependent variable, so its derivative with respect to independent variable will be either partial y by partial x will be equivalent to dy over dx. So dy over dx, which was coming here it is 1 since it was dx by dx. So here is dy by dx. So this is actually the value of written for dy over dx, because in original problem you know y dash is equal to f of x naught y naught. So this is the expansion we are writing for the function of two variables. So plus there will be terms which will be including h square, but since one h is also outside, so I'm using bracket here. So the next term will be having, so when will I multiply with the h, this will be a term with the h, this will be with the h square, so the next term will be h cube. So the terms containing h square in this case and overall h cubes, that will be here. And then we can write it as this one is added to this one multiplied by h, so this becomes 2h f of x naught y naught, plus if you take h square, one h from here and one h which was multiplying from here, so here h square, so h square is taken common, so this will become partial f by partial x at x naught y naught, plus this is taken common, so this will become f of x naught y naught partial f by partial y at x naught y naught, plus terms of order h cube. As I told you, here the terms are of h square, but h is multiplying, so it will become of order h cube. So now this will be y naught plus multiplying with 1 by 2, so this will be cancelled out, it will become h f of x naught y naught, this is fine, plus this will be h square by 2. Now look at this term, actually this term is the value of f dash x naught y naught. So if you recall, for the the knowledge you have for the from the calculus, means the theory of function of several variables, you know for the function of two variables f dash x naught is partial f by partial x into partial x by partial x, means dy over dx by dx, here it is 1, plus partial f by partial y into dy over dx. So this is actually the value of dy over dx. So this together, this term is equal to what? F dash x naught y naught. So this is written as f dash x naught y naught, plus the terms which is of order h cube. So now this, we know this f x naught y naught is h naught prime, the derivative value from the original equation, y dash is equal to f of x. So this is replace this one plus I square this one, this is already derivative, so this is equal to second derivative. So now look at this equation and at this equation, this is the Taylor series expansion. So these two equation coincides in the first three terms or terms up to h square. So here r is 2, so that's why this is called second order RK method. So second order RK method is nothing but the improved Euler's method. So which implies that improved Euler method agrees with the Taylor series solution up to the term h square as I showed you. So therefore the improved Euler method is the RungeKutta method of second order. So in algorithmic form we can write this as increments. If you look at the improved Euler method, so the terms you have is hf of x naught y naught. We are considering this one as k1 and this term as k2. Then if you will look there, k will be half of k1 plus k2 and y1 will be y0 plus k. So in generally this algorithmic shape can be written in the form of k1 is equal to h f of x and yn, k2 is h f of x n plus h yn plus k1, and k is half of k1 plus k2 and yn plus 1 is yn plus k. You can easily get this algorithm. Just go to improved Euler method formula, multiplies all the terms, open all the brackets, and then consider hf x naught y naught is equal to k1. So then you will get another terms, this same terms you will get here, and this term you replace as k2, and you will look there, this the slope was 1 over 2 and this term plus this term. Okay, so this is why, that's why this is half of k1 plus k2. This was the k, and the final term was y1 is equal to y naught plus k. So this you can easily get if you have a look at the improved Euler method. So you can easily write this in the form of algorithmic form. So now going to the third order RK method. So on the similar lines as we discussed in the first order and second order RK method, there is another method which is known as Angus method. Since this is not part of our course contents, so that's why we haven't discussed that method. So but this is another method to solve ordinary differential equation, which is by the Angus. So this is known as Angus method. So since this was not the part, so that's why we haven't included all that here. So on the similar lines, the Angus method agrees with the Taylor series solution up to the term h cube, as in previous case improved agrees till h square and Euler agrees till h power 1. Similarly Angus agrees with h3. So therefore Angus method is the RungeKutta's method of third order. So the algorithm for that method in general form is written here as k1 is hf of x and yn, k2 is hf of xn plus h yn plus k1, k3 is hf of xn plus h yn plus k2, and then k4 is hf xn plus h by 2 and yn plus k1 by 2, and here increment k is equal to 1 by 6, k1 plus 4 k4 plus k3, and the final equation will be yn plus 1 is equal to yn plus the increment k, which can be calculated from here. So हम इन मेथड्स की मदद से हमें फ़ायदा क्या होगा या हम कर क्या रहे हैं, तो हमें ये फ़ायदा होगा कि एल्गोरिथमिक शेप से हमें एक दफ़ा ये के कैलकुलेट करना पड़ेगा और वो इंक्रीमेंट ऐड करने से आपके पास yn plus 1 आ जाएगा. अगले के लिए अगले स्टेप्स की यूज़ करेंगे, ये सारी वैल्यूज़ की मदद से के कैलकुलेट होगा, तो आप ये वैल्यूज़ यहाँ पर सब्सिट्यूट करेंगे तो आपके पास जो भी नेक्स्ट आइटरेशन है उसकी वैल्यू आपके पास आ जाएगी. सो सिंस ये एग्री करता था एच क्यूब टर्म्स तक, तो R3 था, इसलिए इसको थर्ड ऑर्डर आर के मेथड बोलते हैं, एंड थर्ड ऑर्डर आर के मेथड वही है जो सिंपल रंगेज मेथड है. एंड आई एम गोइंग टू रिवाइज हियर अगेन सिंस रंगेज मेथड वाज not the part of our syllabus, so that's why we haven't discussed that method here. So this is the algorithm that you have to memorize and that you must know, and then you can easily solve the questions with the help of these methods. Next, this is the first main method for the RK method, since the previous ones were matching with some of the existing methods we have. So the fourth order RK method is fourth order RungeKutta integration method, represent an appropriate compromise between the competing requirements of low truncation error and computational cost per step. As we discussed in the beginning, I told you in the beginning, that's why that was the problem with the Euler's method. That's why we come across to the RK methods. So this is actually the first method which is making compromise between the competing requirements of a low truncation and computational cost we have. So RK method agrees with the Taylor series solution up to the term H4, and therefore this RK method here I want to mention that we certainly sometimes listens only RK method. So RK method means RK fourth order method. Since previous three methods coincide with the existing model existing methods, that's why जो चौथा हमारे पास फोर्थ ऑर्डर आर के मेथड है उसको सिंपल आर के मेथड भी कहते हैं. तो ये जो आर के मेथड है ये एग्री करता है H4 तक, R4 हो गया तो इस यही फोर ऑर्डर होता है, तो इसको आर के फोर्थ ऑर्डर मेथड बोलते हैं. और इसका एल्गोरिदम जनरल फॉर्म में ये दिया हुआ है. K1 is hf of x and yn, K2 is hf of xn plus h by 2, yn plus k1 by 2, K3 is hf of xn plus h by 2 and yn plus k2 by 2, K4 is hf of xn plus h, yn plus k3, and k is 1 by 6, k1 plus 2, k2 plus 2, k3 plus k4, and this increment will be added in the yn to get yn plus 1. So this is what actually you have to memorize. So once you are asked in any of the questions that solve this example by using RK methods, so this means RK fourth order method. तो जब सिंपल RK मेथड कहा जाएगा तो इसका मतलब है कि वो फोर्थ ऑर्डर RK मेथड की बात हो रही होगी, वो फर्स्ट सेकंड या थर्ड नहीं होगा. तो जब ऑर्डर साथ मेंशन नहीं किया जाएगा तो इट्स मीन फोर्थ ऑर्डर मेथड होगा. और मैंने भी बता दिया कि ओरिजिनल आर के जो मेथड्स हैं वो स्टार्ट ही फोर्थ ऑर्डर से होते हैं, क्योंकि प्रीवियस थ्री जो हैं वो मैच कर जाते थे जो हमने ऑलरेडी मेथड्स पढ़े हैं उनके साथ. Now look at the example. So I'll be solving the same example by using first, second, third and fourth order RK method. So this is the initial value problem given as y dash is equal to x square minus y. Initial condition is given as x is equal to 0, y is 1. So we have to find out the value y.1 and y.2. Means we have to find out these two values. Again, the choice is ours. To reach 0.1, we can from 0 to 0.1 we can directly choose h is equal to 0.1, which I have chosen here, but it's not compulsory. You can choose any value to h. So if I choose h is equal to 0.05, then what happen? Initially you goes to y at 0.05, then you goes to y at 0.1, then you go to y at 0.15, and then you goes at y at 0.2. So यहाँ तक पहुँचने के लिए आपको 4 स्टेप लगते. अगर मैं स्टेप साइज इसका हाफ कर लेता, तो मैं इस एग्जांपल को 0.1 से कर रहा हूँ तो इसका मतलब है एक ही स्टेप में आप आगे चले जाएंगे. सो एच अगर आप स्मॉल कर लें तो आप स्टेप्स को उसकी उसी हिसाब से आपको उतने स्टेप्स करने पड़ेंगे. सो हेयर वी आर सॉल्विंग दिस बाय यूजिंग h is equal to 0.1. so this will be our y1. so we have to find out y1 and y2. और अगर मैं h 0.05 लेता तो मुझे कितने स्टेप्स करने पड़ते? 4. मीन्स ये मेरा y2 होता और ये मेरा y4 होता. तो 2 निकालने के लिए 1 चाहिए होता. ये वैल्यूज इस तरह से यूज़ होती रहती, तो इसलिए जो है वो हमें उसी तरह से करना पड़ता. चूँकि यहाँ हमने 0.1 ही चूज़ किया तो इसलिए हमें y1 और y2 ही निकालना है. सो स्टार्ट विद द फर्स्ट ऑर्डर आर के मेथड. हमें जो इन्फॉर्मेशन पता है वो y डैश पता है, x नोड हमें पता है 0 है यहाँ पर देखिए, और y नोड कितना है 1, और h जो है वो 0.1 है. तो r के फर्स्ट ऑर्डर मेथड में सबसे पहले y 0.1 पर कैलकुलेट करना है. तो y 0.1 पर कैलकुलेट करने के लिए फर्स्ट ऑर्डर का मैंने एल्गोरिदम अभी आपको दिखाया था प्रीवियस स्लाइड्स में. तो वो क्या था कि कैलकुलेट करते हैं h ऑफ x नोड y नोड. तो फंक्शन हमारे पास क्या है यहाँ पर x स्क्वायर माइनस y. तो वैल्यूज पुट की तो x नोड स्क्वायर माइनस y नोड आ गया. उनकी वैल्यूज x नोड की भी है, y नोड की भी है. वो पुट की तो -1 आ गया यहाँ पर, और h 0.1 था तो -1 उससे ज़रा बहुत तो -0.01 आ गया. दीज आर सिंपल कैलकुलेशन जो आप इजीली कर सकते हैं. यू नो द स्टेप, यू नो द फंक्शन, यू हैव जस्ट हैव टू सब्स्टिट्यूट दिस वैल्यू. बट प्लीज़ क्रॉस चेक ऑल दीज वैल्यूज़, क्योंकि मैंने ये लिखी हैं तो माइट बी देयर कैन बी सम इश्यूज, बट यू हैव टू क्रॉस चेक दीज वैल्यूज़. सो y.1 विल बी y1. y1 कैसे निकालते हैं? y नोड में इंक्रीमेंट ऐड करते हैं. तो ये इंक्रीमेंट y नोड में ऐड किया. y नोड कितना था 1 माइनस 0.01, तो वो 0.9 आ गया. सो ये फर्स्ट वैल्यू आ गई y 0.1 पे. तो सिमिलरली इसी को दोबारा यूज़ करेंगे, नोड की जगह पर 1 1 यूज़ करेंगे, ठीक है जी। तो ये y2 हो जाएगा। तो इससे ऑन द सिमिलर स्टेप्स जब आप y2 कैलकुलेट करेंगे तो यू विल गेट दिस आंसर्स। So these are the answers to the y at point 1 and y point 2 by using RK first order method. Now we proceed to RK second order method. So RK second order method 5.1, this is the algorithm we know already. K1 कैलकुलेट किया -0.1 आ गया, K2 कैलकुलेट किया -0.089 आया, इन दोनों को यूज़ करके K कैलकुलेट किया तो -0.0945 आया। सो y1 निकालना है तो y नोड में इंक्रीमेंट ऐड किया तो वी गेट द आंसर 0.9055। तो ये सेकंड ऑर्डर की मदद से ये आंसर आया। इसी तरह y2 निकालना है तो जहाँ जहाँ नोड था वहाँ 1 1 हो गया, K1 निकला हमारे पास -0.08955, सिमिलरली K2 निकला -0.077595। using these two values we get K is equal to -0.0835725 और K इसमें ऐड किया और y1 की वैल्यू में जो y1 की वैल्यू आई थी तो we get y2 as 0.8219275। तो ये y की वैल्यू 0.1 और 0.2 पर है यूजिंग सेकेंड ऑर्डर RK मेथड। अब हम क्या यूज़ करेंगे, थर्ड ऑर्डर RK मेथड। सो फॉर थर्ड ऑर्डर RK मेथड वी नो दिस इज द एल्गोरिदम। सिमिलरली y.1 पे निकालना है तो सबसे पहले K1 निकाला, वो ये हमारे पास आ गया। इसी तरह हमने K2 की वैल्यू निकाली तो -0.089 आई, K3 की वैल्यू -0.0901 आई, K4 की वैल्यू -0.09475। इन चारों को यूज़ करते हुए K निकाला तो -0.09485 आया और y1 निकालना है तो y नोड में K ऐड कर दिया। तो y नोड हमें पता है लीजन वैल्यू जो हमें दी थी 1 में से ये माइनस हुआ तो ये हमारे पास आंसर आ गया। सो दिस इज द वैल्यू ऑफ y.1 यूजिंग थर्ड ऑर्डर RK मेथड। सो सिमिलरली y.2 निकालना है तो जहाँ जहाँ नोड था वहाँ वहाँ x1 y1 हो गया। सो रिप्लेस्ड ऑल दीज नोड्स विद द 1। सो सिमिलरली K1 की वैल्यू हमारे पास आ गई, K2 की वैल्यू आ गई, K3 की वैल्यू आई, K4 की आई। इन चारों वैल्यूज़ को यूज़ करते हुए we get the value of K, and by adding this K to the y1 we get the value of y2. So this is the value of y at point 2, which is y2 is equal to 0.8212449. So now next we'll be using RK fourth order method. So for y.1, this is the algorithm for the fourth order method. First we will calculate K1, this is -0.1, K2 is -0.09475, K3 is -0.950125. Similarly, K4 is calculated as -0.0894987. By using all these four values, we get the value of K using this formula as -0.0948372. And then to find out the value of y1 you'll have to add that increment to the y node. So y node was 1, adding this value of K you will get 0.9051627. So this is the value of y at point 1, which is y1 and which is equal to 0.9051627. Similarly, to compute y at point 2 using fourth order RK method, again the same algorithm, but these nodes are replaced with the ones. So x node is replaced with x1 and y node is replaced with y1. So we computed K1, this is the value for K1. Then we computed K2, this is the value for K2. Similarly, we computed the value of K3 and K4, and using all these four values we calculated K, which is this. So y at point, it should be, it's wrong here, it should be y.2 and that should be y2, which is equal to y1 plus K. So this value is written fine, but here is some type of mistake. It should be 0.2 y2 and y1 plus K. So this is equal to 0.0821269.5. So this is the value of y at point 2. Here are few of the assignments for you to practice this method and have a better understanding of this method. So you have to solve the above listed problem that I just solved in the example which is I am writing it again here. Y dash is equal to x square minus y. Y is 0 is 1. Find y 0.1 and 0.2. That was the original example that I solved. So solve this math example analytically. So this is a first order linear differential equation. Again you will be using the same technique, integrating factor निकालिए, उसकी मदद से सॉल्व कर लीजिए. जिस मेथड से भी सॉल्व करना चाहते हैं सॉल्व कर लें, एनालिटिकली फाइंड आउट करें, फिर उसका एग्जैक्ट सोल्यूशन निकालें. इन दोनों पॉइंट्स के ऊपर एग्जैक्ट सोल्यूशन निकालने के बाद आप क्या करें, जो भी हमने पीछे इन मेथड्स की मदद से आर के फर्स्ट सेकंड थर्ड फोर्थ ऑर्डर से वैल्यूज़ निकाली हैं, उनका डिफरेंस लेकर हर केस के अंदर आपने एरर बताना है. तो आपको एनालिटिकली इसको सॉल्व करना है और इसकी वैल्यू 0.1 पर 0.2 पर निकालनी है और हर मेथड से कंपेयर करके उसका एरर कैलकुलेट करना है. दिस इज योर फर्स्ट असाइनमेंट. सो योर नेक्स्ट सेकंड असाइनमेंट फॉर दिस लेक्चर इज choose any of the problem from book exercise or from anywhere you can take from any of the book. So कोई भी एग्जांपल कहीं से भी कोई भी क्वेश्चन ले लीजिए, उसको सॉल्व करें, बट इट शुड बी व्हाट सेकंड ऑर्डर इनिशियल वैल्यू प्रॉब्लम. और सिर्फ एक मेथड से आपने इसको सॉल्व करना है, किससे, फोर्थ ऑर्डर मेथड फॉर 3 पॉइंट्स एट लीस्ट. मींस ये पहले जो एग्जांपल हमने सॉल्व किए 2 पॉइंट्स के लिए थी, 0 पे गिवन था, 0.1 और 0.2 पे निकाला था. ठीक है, तो आपने एक तो लेनी सेकंड ऑर्डर प्रॉब्लम है और पॉइंट आपने 3 लेने हैं. यानी अगर आप 0 पे लेते हैं इनिशियल वैल्यू और अगला पॉइंट आप h.1 लेते हैं, तो इसका मतलब आपको 0.1 पे, 0.2 पे और 0.3 पे 3 वैल्यूज़ के लिए लेनी है एग्जाम्पल. ठीक है, सेकंड ऑर्डर होनी चाहिए. तो अगेन हिंट मैंने आपको दे दिया, चूँकि सेकंड ऑर्डर होगी तो उसको पहले आपको क्या करना पड़ेगा, कन्वर्ट करना पड़ेगा फर्स्ट ऑर्डर सिस्टम में, और फिर आप उसको आपको सॉल्व करना पड़ेगा. तो सेकंड ऑर्डर लें और 3 पॉइंट्स के लिए सॉल्व करें. सो इट विल इंक्लूड अ बिट लेंथी कैलकुलेशंस, बट ये जो है असाइनमेंट है, ये करने से आपकी इतनी प्रैक्टिस हो जाएगी that you can easily solve any of the problem you come across to solve by using this RK methods. Thank you very much. I hope you understand most of the things, but still if you are lacking in certain things, or I could not explain something, or some other things that need more explanation, so you can ask me through Google Classroom, and for following sources are also available, so you can contact me via these links, and I will try my best to answer all your queries, all your questions. So but do practice, do that thing. When we are going to tell you something, we are just delivering a lecture and then we are skipping these calculation or just showing you the calculation, but it's your duty to do all these calculations. You must check all these calculations. So when we'll be coming across in Google Classroom, I will be telling you all the things, but before you coming to the Google Classroom, when you watch this lecture, please do calculate, to make all these calculations on your own notebook, so that you know what actually is going on. So practice बहुत ज़रूरी है. Numerical analysis it's really very compulsory कि you have to do lot of practice, otherwise when you have been asked to solve any kind of question in exam, you will not be able to even solve a single question in the given time of maybe 2 hours. When you have to solve 5 questions, you will be able to solve only 1 question. So numerical analysis में practice बहुत ज़रूरी है, so practice कीजिए. That's why I am giving you assignments in all these lectures, ताकि आप उन assignments को करें और उनको करने से जो है ना आपकी practice हो, and then we'll be revising the things and we'll be changing certain assignments questions. So your all the questions will be welcomed, and thank you very much. Assalamu alaikum. Allah Hafiz.